How are you guys? Welcome back to my YouTube channel. I was still under fluid mechanics N6. I was still dealing with pumps. So I was still dealing with pump reciprocating pumps. I want us to simply to attack this question so that we understand. Yeah, first I'll advise you to watch all the videos that I've uploaded. You'll check the playlist for pump, watch them step by step. You will check how this thing came about. If you will so that you'll understand this numerical problem, first you must understand the content. If you understand what is going on, then it will be simple for you to attack the question, but I'll make them simple for you so that you attack. I know these types of questions, they do love them. I'll make them to be simple for you so that you attack this question. I'll pick those ones they love, the examiners love them, just to simplify them, to make them. Okay, let us attack. Let us read the statement here. It says a single acting pump. Okay, this is the single. No problem. This is also a double, but this is the single anyway. Has a stroke of, 250 millimeter, and a plunger diameter, as you can see there, here 70 millimeter. The suction pipe diameter, this is the suction pipe diameter has, actually the suction pipe has a diameter of 100 millimeter, is 7, this is 7 meter long. There is a negative suction of 4, right? We have a suction head. There's a negative suction head of 4. The pump is used to pump lime. Is used to pump lime, which is also, it's a liquid form. It's in the liquid form. We used to pump the lime, and then this lime has a relative density of 1.1. Relative density is the same as specific gravity. If you still remember your N5, this is the same as the properties of hydraulic fluid N5. If you don't forget it, just go back and check it. I also have videos for N5 there. We talked about specific gravity. Specific gravity, relative density is the same as specific gravity, where it has no SI units because it's a ratio, right? It's 1.1. The atmospheric pressure, they're giving us a pressure 100 kilopascal, right? And then they said this is, and you see it's a comma there, vapor pressure. This is a vapor pressure at the temperature of the lime is 7.5 pascal, right? Assume simple, this thing is very important, these words. Assume is a simple harmonic motion. This must, you know, when you are dealing with simple harmonic, you already know what is coming on your head. You must know the formula, right? We've discussed about the formula of the simple harmonic motion for the plunger, and calculate the maximum speed in above. You see they want it in res per seconds, at which the crankshaft, this is a crankshaft, this is a crank shaft. That crankshaft can be run before calvation takes place. That means initially 0. This is the beginning of the stroke. That means our teeth will be what? 0 at the beginning. They love this value 0. They will always, you'll always use 0 in the simple harmonic value. Use 0 degrees when you are dealing with, when you're calculating accelerated motion, there is cos there. that cos theta, you suppose substitute 0, which is, we know it's 1. Okay, so they want what? Crankshaft speed. We know we're not talking about speed, we're talking about n. And then where do we get this n? We get it from angular velocity. We know this is pi 2n, right? This will be radians per minutes, but per seconds, like this. Will make this the subject of the formula. So as the aim is to calculate the angular velocity first, so that we'll calculate n. That is the aim there. If we can calculate this, then we'll be done with that. So we know this is a what? It's a simple harmonic. Since we know this is a simple harmonic, then must know simple harmonic. We have the formula for simple harmonic. I've discussed this with you guys. It's H at, right? It's equal to H S. It's up to you. You can say HS, or you can write it anyhow. H separate, same one and the same thing, plus, or that doesn't matter when you add. H separate plus H AS plus HS is a different barometric reading. Remember, this will take from barometric reading, which is barometric reading. We get it from atmospheric pressure head. It's atmospheric pressure head. This is atmospheric pressure head, which is getting from barometric reading. Even if we're given a barometric reading, right, supposed to have this. So we don't know we want to have this ahead. We want to have this head separate, this, and we make this the subject of the formula, right? If we make HAS the subject, we will have HAT minus HSEP, right, minus HS. We want this because we know HA, it's when we have area over, we have this, we have little length, small length, over gravity multiplied by area over the small area multiplied by this angular velocity, right? When we multiply by that angular, we know that we multiply by r cos theta. So why are we using this? So that we'll calculate this. Why we make this subject of the formula? So that I'll calculate the angular, then I'll find what the speed, right? That is why I take that steps. I took these steps. So you must ask yourself, our formula, we must follow this formula. Is for simple harmonic, right? So there I've made the subject of formula, the accelerating head. So now when this is a head, yes, it's a head. So let us read the statement to see whether we have the heads or we don't have the heads. Now, a single acting plunger pump is a stroke off. We have this, the plunger diameter, the suction pipe is a diameter. Okay, there is a negative suction head. We have a head, suction head, right? We have suction head. This one, we have it from the statement. Let me tick it. We have this one. Already we have this one. I've ticked it. And the pump is used to pump lime with the relative density. We have the relative density, the atmospheric pressure. You see, they've given us the atmospheric pressure. Remember, this, it's a head of the atmospheric. It's measured, you use barometric reading to measure this head. But now we have given the atmospheric. Okay, no problem. We don't have this, but we have the atmospherics. We don't have the head, but we have the atmospheric, right? You must know that. You must note that. And the viper of the pressure of the slime is 1.7. Yeah, the viper. This is a viper. This is a what? The viper. The viper. This is what? It's water, right? The viper at the temperature of the slime, which is SEP. separating what? This is for separating what? We have given the vibe. But here we're given in terms of what? Of a pressure of 1.7 kilo. We're not given the head. Here we're given 1000, but it's not the head. So we're supposed to have what? Heads, not pressures. This is measured in meters. So we have this, but how can we find the heads of this? Now it's when you apply your knowledge of fluid mechanics, what you have learned in your previous grade. You know that relative density, they've given us a relative density. Remember, this is the same substance that we are using, the lime. Now we want to know what is its relative density, right? So they've given us the relative density. What we want to know, we're supposed to calculate rho, the density of this lime. Okay, we know the formula. Specific gravity, relative density is the same as specific gravity. You know, you can write relative density is equal to the, remember here, density of the substance divided by standard density of water, always of water. So we know relative density of this lime, the substance here, it's lime, you can write it's a lime, but we know the substance is lime, the water we know is 1000 density of water. Now let's calculate, substitute the relative density they've given us is 1.1. We put 1.1. P of the substance is what we are looking for. We can write this lime, density of lime over of water is 1000. Of water is what? Is 1000, isn't it? Cross multiply that side. P lime must be equal 1.1 multiplied by that 1000, right? 1.1 multiplied by 1000, you get 1100, right? This is kg per cubic, right? This is density. Now we have the density. It's fine. Now we have the density. Why at the first place we calculated the density is because you want to find. Now we've given, this is a pressure. We've given these things in terms of pressure. We come here, remember they've given atmospheric pressure as in the atmospheric pressure, not the atmospheric head. We know pressure is equal to density multiplied by gravity, we'll multiply this by HAT. Remember, it's a head of the atmospheric, right? They've given us the pressure, but us in our formula, we want the head. We don't want to use directly the pressures, we use the heads. So you substitute the pressure, which is 100, which 100 will multiply by 1000 because it's kgs. Your SI units, 1000 times 10 to the power 3. It's equal. The density will be the same. We're using the same water throughout. The water that we are supplying the pump, the liquid, it's a lime. It's same throughout. There's no, it's the same. So it's the same. No, we know that we'll have. This is our density we have calculated here, 1100, right? Then we'll multiply this by 9.81 multiplied by HAT, right? Now we want HAT, you divide this, HAT must be equal, you divide this, will be 1000 times 10 power 3, divide this by 1100 times 10, 1, right? Punch this on your calculator. Let's see what you got. When I rounded to 3 decimal place, HT, I found that is would be 9,267. 267. Remember here it is measured in what? In mid. This is H A T. Common our formula we tick. Oh, we already got this body. Hey buddy, we have you because we have just calculated you. Now we have this, we are limited by this H sub. Hey buddy, how can we calculate? You ask yourself, how can you calculate this? You check, you return back here. You say this, you know, is this what separating what separate. It's a separation with separating what. This water, remember, water might be the form of, will be in the form of vapor. The form can be a form of solid, form of liquid, but it's the separating of what? Of what? Now of that, or the separating of that liquid. So let us check something that talks about liquid or that talks about vapor. Okay, let us check the head or something that talks about separating head in our statement, what we have given. Now if we read here, you see a vapor. We have a vapor pressure at the temperature of a slime is. They've given what? They don't give they did not give us the head of the separating, but they decided to give us in terms of a pressure, not in terms of head. So we know, okay, they think that they are clever. We know, we have learned our fluid. We know that pressure is equal to rho. We know this rho will be the slime. We know our formula. Multiply, let me just say, density multiplied by gravity multiplied by H separate. You want the H sep. Hey buddy, we can make you the substitute formula. Then we know this is what we have. This pressure. Here's this. They've given us it's 1.7 multiplied by 10 power 3. This is lime because it will be the same liquid throughout the pump. We have calculated it from here. Substitute 1100 multiplied by gravity 9,81 multiplied by H sep. Okay. What there is not bad. It's not bad. You divide this, you'll have H sep. You divide now 1,7 times 10 power 3 divided by 1000 0 times 10 to the negative, okay, times 9,81. So about it, divide, punch your calculator. Okay buddy, let us have H sep. Okay, let's see this guy. Okay, decided to become 0,158. Okay, this guy decided to become 1,58. When you punch it on your calculator, it's measured in meter. Remember, it's a head. We have this. Fine. We come. Now we can have, we already have this 3. We can strictly substitute on the formula and calculate. We can simply substitute our stuff there. We come. HAS, accelerating hand. HC, where are you? We've calculated you. Here you are. Okay, it's fine. Okay, we can see you. You are 9, something there. Let us just put you there. You are 9,267, buddy. You subtract. Hey, what about you, buddy? H separating. This guy is equal to what? H separating. This guy is 0,158. What about this guy? We've given it from the statement, which is 4. Section here. This guy is 4. You punch the calculator. What are you getting there? Punch the calculator. Tell me, what do you got? Let me see. As I punch mine, this body gave me. This body will be H. AS will be equal. Punch all of this on your calculator. I decided, I got 5 comma 109 meter. This is now the question did not say we should calculate the accelerating height in the section that you want us the speed, but the steps. So, but for us to calculate the speed, we're supposed to calculate the accelerating because we know our formula. It's where we'll find what, it's where we'll get the angular velocity. Also, the angular velocity is the one that will help us to calculate what is needed here. Right, it's comma 9 here. We have this now. Right, we are done there. So now we want to calculate what the speed that they are talking about. Oh, but now they want, these guys, they decided, you know what, we want this speed. They want to calculate this speed. They want us to calculate this speed. Okay, it's fine. Now we know this h, it's equal to, you know, the formula, length of the pipe over gravity multiplied by d squared over d squared multiplied by angular squared is what we are looking for. Angular squared will help us to calculate the speed multiplied by r multiplied by cos theta. Right, so we have this part here, so we can replace that. Let me erase. Can I erase? So please, you can screenshot here. Can I erase there? Can I erase there? I hope you can just take the screenshot there. I hope you took the screenshot. Let me erase here. Can I please erase here? Right. We know this party. We know the party is equal to HAS is equal to length of the pipe over gravity multiplied by, you can say d over d squared multiplied by angular squared multiplied by r multiplied by cos theta. Right. Now theta, because this is before, we must note something. Before or when we had the before calculation or starting cavitation, you must know that theta is 0. Remember, we are at the suction side where the suction at the start, theta will be 0. Remember, it's not in the middle, it's on the starting of the stroke, which is theta will be 0. This will be 0. Theta, when you put 0, remember, cos 0 it's 1. Right, in other words, so here when I put 0 here, this will eliminate this cos, then we'll be left with something like this. Remember, cos 0 it's 1, so all left is the equation will be just like that. So let us substitute. We know this, it's 5.109, right? What about the length of the pipe? This is a small length. The length of the pipe. What is the length of the pipe? We want to know. Why in the question they talk about the length of the pipe? The pipe, you see, has a diameter. They've given the diameter and is 7 meter long. You see, that pipe is 7 meter long. Okay, you see, you can write 7 over 9,81 multiply the diameter of the plunger. Remember, D, big D, the capital letter D will be diameter of the plunger. Diameter of the plunger. Where is the plunger? You can see the plunger diameter 70, which is since it's 70, it is 70, ne? The diameter of the plunger, it is 70. Yeah, plunger diameter, it is 70. Whereby we divide that thing by plunger 70, you divide by 1000, right? It will give you 0.07. This will be 0.07 over the diameter of the pipe here, 0.01. It's indeed 0.1. Sorry, 0.1. 1,100 divided by 1,000 will give you 0.1. If I'm not mistaken, this will be 0.1, right? All this square that, multiply angular view is what we're looking for. We don't know. This is squared, right? This square. Say square here, multiply by r. I said r. You remember it is a stroke length, divided by 2. Then let us check the stroke length. We have the stroke length. The pump has a stroke of, it is a stroke 250 millimeter divided by 2. Punch, you calculate. What will you get if you divide 250 divided by 2 is 1. Just give me 125 millimeter. What about in meters? We divide this by 1000. 1 this to will be 0.125 meters. Right, we have shown that this will be 0.125, right? 0.125. Punch this on your calculator. Okay, you can write this 5.109. Then I punch this on the calculator. You know what? You can make it simple. Punch this, because these are terms those are like terms. These are constants. You can punch the constants, all them like this. You can say multiply this, punch this on the calculator and multiply by 0. Let me just say 9.81 into 0.07 over 0.1 squared. Take this because it's a constant, 0.125, then w squared, right? Punch this, all of that. Let me function 7 divided by 9.81, right? You multiply that all into 0.07 over 0.1, then you square that, multiply all of these by 0.125. I don't know, this is what I got. I don't know what you got. This is what I got. 0. I call this. Let me not convert it to. First, I will not convert it to, because not the final answer. Let me take out 0.0443 white, 0.43705 right, multiply by w squared. I just make to this decimal because not the final answer. So then I divide this by 0.043705, 0.043705. This and this will cancel. We have w, right, squared. Let me just take squared both side. Take the square root both side. Square root this. we left, remember when divide we'll have this. Yeah, we left with something like this. Let me just say we'll have something like this, which will be 5,109 over 0,043705. Take the square root both side. Square root both side. This will be W. Punch this on your calculator. Square root of 5,109, right, 0,043705. Okay, this is 10,812. Remember, right? 2. This must be in reds. It's measured in reds. Let me just say reds per second. Right, because remember that is not a final answer. Right. That is not a final answer. Let me double check this. Let me punch this. Let me check that. Did not do any mistake there. 0,07 squared. 0,07 over 0,1. All these squares. After you multiply this by 0,125. Then I get 0,04375. Is right, yeah, is correct. This is right. Then we know this W is equal to 2 pi n. We want it. Remember, they requested us to leave this the seconds. We don't divide by 6. Because they want it in what, in seconds. So we take this straightforward. Then divide here. Just divide this by 2 pi. Also here by 2 pi. Then n with W over 2 pi. Then that is 10,812 over 2 pi. Right, this is n. Take 110,812 divided by 2 pi. I just got this, and the speed is 1,721 frames per second. Let me write it. 1 right is 1,721 frames per seconds. This is the answer here. That is it. It's not that bad. It's not that bad. So if you, it's not that bad, not that bad, it's not that bad. Hopefully you understood this, guys. Thank you, guys. You can comment and like, share this video to your fellow classmates, and also do not forget to subscribe. Stay tuned. Stay tuned. Also, I'll be posting some videos explaining to you guys. As you can see here, there's no air. There's no air vessels that is filled. We have discussed about air vessels. We will discuss again about air vessels. Good. Sharp.